there are LaTeX parsers for Mac and Intel, other machines that are free. And if someone can do this on a regular basis, they could just do it from that. They could enter in what they want, and then they would parse out.
Yeah, my own personal feeling about that is when I then try to enter variable names in there, things get a little bit crazy because I'm not keeping track of them like I should. Yes?
I'm sorry, is this time for comments or just questions?
Questions or comments, I don't care, but we are only about maybe a third, maybe halfway through the whole thing.
Okay.
Is it a short thing or a long thing?
Very short.
Okay, go ahead.
This is a recipe for having people not use it.
Agreed.
Okay.
So this, though, is something that if you think that this is a useful thing to ask your students to do, then we can make it easier for you to use it. Yes? No?
Well, I'm speaking of this input right here.
Right. So
and a non-WYSIWYG sort of input up above. And
so you would rather have the other palettes that we have available for other question types?
I think there's going to be about 10 to 20% of the faculty who are sufficient, no, that's probably too high, 5 to 10% of the faculty who are sufficiently comfortable with text that they're comfortable putting in questions and answers like this. And migrating to have that palette feature, which is available on all the other question types, because it is there. It was a real project that Shane and others went through, and it's a really nice palette. It's like a Microsoft Word editor. So it's available, and it just needs to be made available on this question type as well.
Are you all familiar with the palette we're talking about?
No, I think not, but we do need to move on, but I think we need to assure everyone that it exists and it can be made here, and then it's probably useful to get your comments on that palette and how usable it is. It was made to look like Word in the sense of editing in superscripts and all that kind of stuff, but
you can also use not playtext, LaTeX in those questions.
Wait, you can't use LaTeX?
So for those questions, well, I guess it depends.
You mean you got to switch between plain text and LaTeX?
I think it depends on which one you're doing. Shane?
It depends on which one you do. So the palette question, we've got multiple types of questions, and the palette supports like LaTeX or HTML, or there's just a variety of things you can do. What we're looking at here with the editor is sort of the seedy underbelly that will allow you to do very, very complicated things, if that is what you so desire. You can create problems that have dozens of variables, and every student gets custom drawn charts and graphs. If you don't care for that level of sophistication in crafting a problem, then the palette editor that Sasha's telling us about is a very simple way to build problems. And yeah, it supports LaTeX, it supports HTML, and soon you can support algebraic free response. But right now, the way you craft the algebraic free response problem is using symmetrical machine.
Let's table, if I may, because I think there's lots of really good feedback you're getting here. But let's structure a future one of these sessions where everyone can see the various ways to actually enter in a problem. And I think that would be a good focus for another one of these. But I share your kind of looking at the clock here. We want people to see what are the kinds of questions that can be written in Mathematica and how maybe they can get their head around writing questions like that. And we can talk about implementing the problem at a later time.
So there's WebMathematica and Mathematica give us two very powerful capabilities. One is the ability to verify these algebraic free response answers, and the other is to make these online simulations that are pretty standalone. You don't need any downloaded software for them. So for one example is that we have a tool here that asks a student to investigate how changing the parameters in this sign function, the a, the b, the c, and the d, changes the graph. So if I change a and make it littler, here's something that, so watch. If I click on it, it tells me what the value of a is currently. If I move it, notice that my graph hasn't yet changed. This is an issue that is, well, a difference between Mathematica and what happens when we implement this in an online environment. So it changes and updates once I've actually let go of my pointer, but it still tells me what the number was that I happened to choose. So the mechanics are that it takes the value of the slider, it sends it to the server, and the server sends back an image. So this is not a dynamic update. But I can also attach questions to these little explorations, and I can ask a student, okay, so really, how did changing A affect the graph? And there are some choices here. And how did changing B affect the graph? So part of this is, when we first got WebMathematica capabilities, we really were not exactly sure how it works and what its capabilities are. So what I have here are some of the things that it will do. You can manipulate graphs. You can also use it for, say, demonstration purposes in your class. So this is a demonstration on how cylindrical coordinates work. I have 3 parameters that I'm allowed to change at will. So again, this is the sort of thing that it gathers the parameter for theta that I've just changed, and it will update the image. So you can talk to them about how spherical, or in this case cylindrical coordinates work, but I'm working on your spherical.
Good. You have 3 weeks.
Yeah.
Anyway, that's really nice of it.
Thank you. So, well,
It looks better in color now.
I wanted to choose non-garish colors. So here, I mean, there are all kinds of things that you can do in a math context. You can also build, so this is a 3D plotting tool. So I can plot the sine of x times the sine of y from minus pi to pi in the x, from minus pi to pi in the y. Sorry about the button. And it will output for me a 3D surface that I can spin around and look at how the thing works.
Can you then go back and change that to 2 pi?
I absolutely could. Which one?
Right there.
I'm going to put in the multiplication sign just because I have cardinal rule of demos. Never touch a button you haven't touched before. But yeah,
Okay.
I
So
can
they could
change this
see
to
the
2 pi.
effect. Okay.
And then you could write questions about the graph or about the representation here, which I think is really,
Just like we did
Likewise.
with the sign transformation question. We could ask
So you
them to
could
choose
actually
the
use
numbers.
this more than just math, because you
Yeah.
could use Mathematica to represent things that you've mathematically represented in biology, chemistry,
Yeah.
physics.
Yeah.
So you could do a ballistics problem using Mathematica where it would redraw this
Mhm.
and it would apply to other than just math students.
So here I have a different simulation, and this one is borrowed from the Wolfram Demonstrations Project. So Wolfram, which is the maker of Mathematica and WebMathematica, they have a demonstrations page, and this will give us some ideas about what we can do with Mathematica. So one of the things is that this is an entropy simulation. I can start with a certain number of particles in the left-hand box, a certain number of particles in the right-hand box, and I can step through updating these and see how my states change over time. Also, I'm plotting at the same time an entropy curve that tells me how disorganized my states are. So there are lots of good ideas about things that we can implement on this platform. So this is another example of a question that is tied to a WebMathematica simulation. Here, we're asking for the eigenstates of, well, so you have a mass M, potential well of length L. Sasha, how am I doing? This is your question.
Quantum mechanics problem.
Quantum mechanics problem, thank you. And I'm asking the student to report what is psi 1 of x when t is 0. And so the correct answer here is this. The reason I wrote that here is that this is what the student can put in this little box using the appropriate syntax, and it would be graded correctly and appropriately. This is totally fine for us now. We can accept these kinds of answers. And there are tons of them, because there are lots of parts to this question. But at the very, very bottom, we can ask them to plot these functions that they found above. And the punchline here is that these things are not time dependent, so that they can see, oh, I'm plotting these, they look the same whether I'm at half of my period or at t equals 0. So these, Mathematica calls them manipulates. You could also call them simulations. These are certainly embeddable in problems. The next part of this question is that you look at the superposition state, and when you graph it, so this is the quantity that I'm graphing here, and as I change t, I can watch the graph change. Appropriately exciting?
I'm pretty excited right now.
That's what I wanted.
How do I see this? Oh, T is that little tiny
T.
dot to the left there.
Yeah.
T
Okay.
is on the slider right here.
For those of us that can't see it, okay.
Yeah.
Why
Do I
is
need
this?
to turn the lights off more?
No, it's just very small.
Yeah, it looks better when you're not looking at it on a
So if you wanted to investigate, or then ask a series of questions of the students about the graph
Yeah.
that they can manipulate, you could now search
What
for.
So just in terms of interface, obviously you've created this in a linear page,
Mm-hmm.
and are you able, I'm not suggesting you use frames, but having the question next to the diagram rather than having to scroll would be a big difference.
So I'm not.
Yeah, we can-
Yes,
we can
you
change
can
the
because you can.
Surely
make
you
the
can parse that
linear
page not
columns.
even using frames to do that, yeah.
Do have, so, oops, we didn't do very well.
You seem to have an animation feature in the last one you showed, but not in the first one, in the cylindrical coordinate one. Why was
An
that?
animation feature,
No,
like
she
making
changed
it
T.
play all by
As
itself.
you were changing the t, the graph was adjusting
Oh.
corresponding.
So the reason is that for that particular graph, it's actually in the code, it's a 3D graph. So changing incrementally those parameters, it's a lot for the server to regenerate the picture and send it back. But for that simple one-dimensional curve, it wasn't hard at all.
That's fine, okay. So it's a 3D problem, it's not a
Yeah.
conceptual problem.
So the surface that I was wiggling around, those things, that's interesting. So those things load a plugin on your computer, and that
Okay.
rendering is done locally. So it was very, very fast as you wiggle it around. Okay, so those are the things that we now have using WebMathematica. So what else do you want to see? What do you want to see it do? You're
Well, I think
all
that you
up.
should, I think that showing that this could be integrated into other disciplines would go a long way.
Oh,
And-
hang on. Sorry. Thank you. Okay, so we can also talk, so one of the great resources that Mathematica has is a curated database of knowledge. For example, they have all of these like substructure diagrams for molecules. You can make space filling. Whoops, where'd it go? Oh, I'm sorry, I touched the button. Show all the information, show all the ends. Anyway, they have these structures preloaded, and we can access them once our permissions are all sorted out. But we have access to this database as well. And lots of population data for states and countries.